warahmatullahi wabarakatuh. To carry on with the embryology lectures, I'm going to discuss in this presentation the development of the veins. I'm Dr. Dalia Saleh, professor and head of anatomy department at Mansoura University, Egypt. For the objectives of my presentation today, I'm going to discuss the development and derivatives of each of the following: of the vitelline veins, of the umbilical veins, of the cardinal veins. We will talk about the development of both the superior and the inferior vena cava and their anomalies. At first, we need to know that the embryonic venous system consists of the following sets of veins. We have vitelline veins, which drain the yolk sac and the developing gut tube. The umbilical veins, which bring oxygenated blood from the placenta to the fetus. The cardinal veins, which drain the rest of the body, meaning the body wall, the limbs, the head and neck. Initially, these veins are bilaterally symmetric and they drain into the horns of the sinus venosus. And if you remember, the sinus venosus was the inflowing part of the heart tube, which receives the venous return from the embryo. So we have two vitelline veins, right and left. We have two umbilical veins, right and left, and two common cardinal veins. As you notice, they are bilaterally symmetric, meaning that we have three on the right side and three on the left side. Let's start first with the development of the vitelline veins. In this picture, we can see the side view of the embryo. This is the cephalic end of the embryo. This is the head. And this is the caudal end of the embryo. Here we can see the heart loop. It has an inflowing part made of the sinus venosus and the veins draining into it, and outflowing part made by the truncus arteriosus and the arteries coming out of it. And this is the dorsal aorta. Here you can see the yolk sac protruding outside the umbilical cord like this, connected to the inside of the embryo with the developing gut tube. So there is a venous plexus that invades the wall of the yolk sac and the developing gut tube, which collects into right and left vitelline veins, as I mentioned before. In this view, we can only see the body of the sinus venosus and its two horns, and the veins draining into these horns of the sinus venosus. So remember, the vitelline veins are the most medial ones. So as they pass around the duodenum, they communicate with each other with channels. Some lie in front of the duodenum, some lie behind it. The growing liver cords starts to develop in this region and invades, as they grow, the vitelline veins. So basically, the liver cells will break down these vitelline veins into small sinusoids. The vitelline veins within the liver, they will be broken down into the liver sinusoids. Then the liver sinusoids will collect again into two channels that communicate the vitelline vein to the sinus venosus. We call them the hepatocardiac channels. So we have right hepatocardiac channel and also left hepatocardiac channel. Okay, so again we have two vitelline veins, right and left, communicate with each other around the duodenum by channels. They get into the liver and break down into hepatic sinusoids and then drain into the sinus venosus through right and left hepatocardiac channel. What will happen next? So as a result of this left to right shunt of the blood, most of the left vitelline vein will degenerate or disappear, and the anastomosis around the duodenum between the right and left vitelline veins will end up in forming the portal vein and its two veins that form it, namely the splenic and the superior mesenteric vein. The left hepatocardiac channel will disappear and the right hepatocardiac channel will persist and enlarges and form the posthepatic segment of the inferior vena cava. For the umbilical veins, let's again revise this picture, we have the developing gut tube, we have the sinus venosus with its two horns, we have the two vitelline veins are the most medial ones, and this is the developing liver, and we have on each side the two umbilical veins. They bring oxygenated blood from the placenta to the fetus, and on the lateral side we have the two common cardinal veins. So the two umbilical veins develop after the development of the vitelline veins, and they lie on each side of them. And as you know, they transmit oxygenated blood from the placenta to the fetus. At first, the two umbilical veins pass on each side of the liver to terminate into the sinus venosus. As we can see here, these are the two umbilical veins. They lie on each side of the developing liver and they terminate into the sinus venosus. But with further development and enlargement of the liver, they get connected with the hepatic sinusoids. So the umbilical veins here on the right side and on the left side, they get connection with the hepatic sinusoid. But you can notice that they are still connected with the sinus venosus. But with further development and the growth of the liver, they lose connection with the sinus venosus. So the part of the umbilical veins that terminated in the sinus venosus, both on the right and on the left side, they will shrink and disappear. As you can see here, the proximal parts of both right and left umbilical veins and the connection with the sinus venosus will disappear. Also, the distal part of the right umbilical vein will degenerate as well. And we will end only with the left umbilical vein, which enlarges, and now it is the only vein that carries the oxygenated blood from the placenta to the fetus. And with the increase of the placental circulation, another shortcut is developed to bypass the hepatic sinusoids in order to deliver the oxygenated blood faster to the inferior vena cava. This shunt or this shortcut, we call it the ductus venosus. After birth and clamping of the umbilical cord, the left umbilical vein will degenerate and the remnants of it in the adult will be the ligamentum teres. Also, the ductus venosus will shrink and will form the ligamentum venosum in adult, and even we can notice that part of it is still connected to the inferior vena cava. Next, we'll talk about the cardinal veins, and it is a little bit complicated than the vitelline and the umbilical veins, so bear with me. So initially, the cardinal veins are symmetric, made of the following: anterior cardinal veins, posterior cardinal veins. They drain into the common cardinal vein. We have one on the right side and another one on the left side. The anterior cardinal veins, as can be seen in this picture, they drain the head, the neck, and the upper limb, while the posterior cardinal veins drain the rest of the body, mainly the body wall and the lower limbs. So the anterior cardinal veins will eventually end up forming the superior vena cava and the veins draining the head and neck and the upper limb. So the distal part of the anterior cardinal vein on each side will form the internal jugular vein, while the subclavian vein will develop from the seventh intersegmental vein. This is a vein that lies opposite the proximal end or the root of the upper limb body. We have a channel of anastomosis between the anterior cardinal on the right side and that on the left side. This channel or anastomosis will give us the left brachiocephalic vein. The proximal part of the right anterior cardinal vein will form the right brachiocephalic vein and the part of the superior vena cava that lies outside the pericardium. The proximal part of the left anterior cardinal vein will degenerate, except for a small part that will give us the left superior intercostal vein. This vein drains the upper 2 or 3 intercostal spaces on the left side. The right common cardinal vein will form the superior vena cava, which lies within the pericardium, while the left common cardinal vein will shrink, and the remnant of it will be the oblique vein of the left atrium, which opens into the coronary sinus. What about the anomalies of the superior vena cava after we know how it develops? If the channel between the two cardinal veins did not develop and disappear, so we will end up with no left brachiocephalic vein. Instead, we will have persistence of the left anterior cardinal vein forming the left superior vena cava. So we will end up with double superior vena cava, one on the right side and one on the left side. The one on the left side will join the coronary sinus and opens into the right atrium, as we can see here from a back view. So this is the superior vena cava. Now it is on the right side, made of the right internal jugular and right subclavian veins, opens into the right atrium. On the left side, we will have the left internal jugular vein, the left subclavian vein, forming the left superior vena cava, which join the coronary sinus and terminate at the right atrium. So this case is called double superior vena cava. Another anomaly we can see in the development of the superior vena cava, that we have left superior vena cava and the absence of the right superior vena cava. So in this case, there is degeneration of the right cardinal veins distal to the anastomosis between the two anterior cardinal veins. So this is the anastomosis, and the rest of the right system will degenerate in this area. So we have persistence of the left anterior cardinal vein forming the left superior vena cava, which again joins the coronary sinus and opens into the right atrium. So venous blood from the right side, which comes from the right internal jugular and right subclavian, will pass through the brachiocephalic vein, left brachiocephalic vein, into the left superior vena cava, into the coronary sinus, and terminate or opens at the right atrium, as we can see here from a back view. Now we move to the development of the posterior cardinal vein. The posterior cardinals will mostly degenerate after being replaced by another pairs of longitudinal veins to take over their function. If you remember in the beginning, I said the posterior cardinal vein will drain the body wall and the lower limbs. So we will have other sets of veins that will take over this function. The first sets are the subcardinal veins, the ones in red here. They are mainly veins that will drain the structures that will develop from the intermediate mesoderm, mainly the mesonephric kidney and the gonads. Another set of veins on each side of them are the supracardinal veins, and the part that will persist from the posterior cardinal veins, we will call them the sacrocardinal veins. They will drain the lower limbs. As a result of shunt of the blood from the left side to the right side of the embryo, a number of anastomoses appear between these sets of veins. So you can see here that two subcardinal veins have anastomosis with each other, and also anastomosis with the posterior cardinal vein, and the important anastomosis here between the subcardinal and supracardinal vein, the yellow one here, we will call it supracardinal anastomosis. The two supracardinal veins also communicate with the posterior cardinal veins both cranially and caudally. Another important anastomosis between the two posterior cardinal veins here, we call it the iliac anastomosis. So most of the posterior cardinal veins will degenerate except for its proximal end on the right side, and this will form the arch of the azygous vein, or the termination of the azygous vein into the superior vena cava. The distal part of the two posterior cardinal veins and their communication, so they will form both right and left common iliac veins. What about the development of the subcardinal veins? As we can see here from this picture, there is modulation of the venous system due to shunting of the blood from the left to the right side. Just follow the red vein. So the right subcardinal vein will persist and form a segment of the inferior vena cava. It will also on the right side form the right gonadal vein and the right suprarenal vein. The anastomosis between the two subcardinal veins will form the left renal vein. The left subcardinal vein mostly disappear or degenerate except for the left gonadal vein and the left suprarenal vein. For the supracardinal veins, focus on the veins that are in green. We have two parts of the supracardinal veins. Part lies in the abdomen and another part lies at the thorax. So with modulation also of these veins due to left to right shunt, the left abdominal vein will disappear, while the abdominal part of the right supracardinal vein will persist and form a segment of the inferior vena cava between the renal and the iliac veins. Here we can see this segment of the inferior vena cava between the renal and the iliac veins. The thoracic part of both right and left supracardinal veins will form the azygous venous system. The azygous vein on the right side and the hemiazygous on the left side, and they communicate with each other. So let's summarize the development of the inferior vena cava. Let's look at this picture again and see the modulation of the cardinal veins and how they form the inferior vena cava. We need to know first that the subcardinal vein also communicates with the posthepatic segment of the inferior vena cava that was derived from the vitelline vein into the sinus venosus. Okay, so the inferior vena cava develops from caudal to cranial as follows. The most distal end of the inferior vena cava, we called it the sacrocardinal part. And then we have the postrenal segment. It is made by the right supracardinal vein. And then we have the renal segment made by the supracardinal anastomosis. In this region, you can see the termination of the two left and right renal veins into the inferior vena cava. Then we have the prerenal segment made by the right subcardinal vein. And then we have the hepatic segment made by the anastomosis between the subcardinal vein and the posthepatic segment of the inferior vena cava. We call it the subcardinal hepatic anastomosis. And finally, we have the posthepatic segment made by the right hepatocardiac channel or the termination of the right vitelline vein into the sinus venosus. As you can see, the development of the inferior vena cava is a complex process, so anomalies might arise. So the first anomaly we have here is absence of the inferior vena cava. If you look at this diagram or this region, you're going to see that there is a connection between the subcardinal vein and the hepatic part of the inferior vena cava. What if this connection does not happen or there is degeneration here? So the subcardinal hepatic anastomosis is absent. The rest of the inferior vena cava will join the azygous vein in order to drain its blood into the right atrium. So we will end up with something called absence of the inferior vena cava. Only the liver drains by a small segment into the right atrium, while the rest of the inferior vena cava, as we can see here, join the azygous vein into the superior vena cava to terminate at the right atrium. The other anomaly is called double inferior vena cava. This anomaly occurs when there is persistence of the left supracardinal vein on the left side. So we will have a left inferior vena cava which lies below the left renal vein. as we can see in this anomaly. The anterior vena cava on the right side develops normally, and we have another one below the level of the left renal vein, as we can see here. This is the end of my presentation. Thanks for listening. If you like it, please do not forget to subscribe, like, and share, and hit the notification bell so you can be notified when I upload another video.